Kia ora guys, welcome back to the Year 10 Physical World series, Forces in Motion. This is video 7. In this video, you'll be learning about distance, speed, time, and acceleration with respect to an object's motion. And by the end of this lesson, you should be able to use the change in distance equals speed times change in time equation with the correct units to calculate the change in distance, speed, and change in time. And you should be able to use the change in speed equals acceleration times change in time equation with the correct units to calculate the change in speed, acceleration, and change in time. So when we're describing an object's motion, we tend to use these measures: distance, time, speed, and acceleration. How far an object moves is the distance, and we abbreviate distance in the small d. And it's measured in meters, and we abbreviate meters with the small m. How long an object takes to move is the time, and time is abbreviated with a small t. And time is measured in seconds, the small s. How fast an object moves is the speed. That's abbreviated as the small s and is measured in meters per second, ms to the power of -1. How fast the speed changes is the acceleration, and you already know that acceleration is abbreviated as a small a and is measured in meters per second, abbreviated as ms to the power of -2. Here's an activity. I would like you guys to use your brains and think. Can you think of what other units we can use to measure distance, time, and speed? Can you also think of what we can use to accurately measure distance, time, and speed? So these are the measuring tools we use to measure distance, time, and speed. What do you think? Let's look at how we calculate each of these measures. First of all, we'll look at calculating speed. To calculate speed, you need to divide the change in distance by the change in time using this equation. So average speed equals change in distance over change in time. And that can be abbreviated by these equations, these symbol equations. Here's a question for you guys to answer. If this dog slides 15 meters in 5 seconds, what's its speed? How fast is it moving? Here's another question. If Jonah Lomu runs 50 meters in 8 seconds, how fast is he moving? Now let's look at how to calculate distance using this equation. To calculate the change in distance, that's what the triangles represent. The triangles represent a change in something. Change in distance here and change in time here. To calculate this change in distance, you need to rearrange this original equation. After we rearrange it, we know that to calculate the change in distance, we need to multiply the speed, the s, with the change in time taken for the object to travel, change in t. Now let's look at how to calculate the change in time. To calculate the change in time taken for an object to travel, you must rearrange this original equation. Once you've arranged the original equation, you'll see that to calculate the change in time, you have to divide the change in distance traveled, change in distance, by the speed of travel, divided by the s. This is a really good video explaining the distance, speed, and time equation. We'll be watching this video in class. Alright, now there's this other equation, acceleration equals change in speed over change in time, that we use to calculate acceleration. So to calculate acceleration, we need to divide the change in speed of travel, up here, by the change in time taken for that object to travel, using this equation. This is the word equation, and this is the symbol equation. So using this symbol equation, how do we calculate speed? To calculate the change in speed of an object, you need to rearrange this equation to this. After rearranging this equation, you'll see that to find out the change in speed, you need to multiply the acceleration, symbol a, with the change in time taken for the object to travel, change in t. And to calculate the change in time, you first need to rearrange this equation. After you rearrange this equation, you'll see that to calculate the change in time, you need to divide the change in speed, shown by this symbol, by the acceleration of that object, shown by this symbol, a. We'll get more practice in using those equations to calculate distance, time, speed, and acceleration in class. But before we do that, I would like you guys to update this table of quantities in an international system of units. In the previous lesson, we took these ones down, but today, please copy down these new symbols and units and measures. So we learnt about distance, which is the symbol d, and it's measured in meters, which is the symbol m. We learnt about time, which is the symbol t, and it's measured in seconds, which is the symbol m. And we also learnt about speed, which is the symbol s, and it's measured in meters per second, which is the symbol ms to the power of -1. We also learnt that acceleration is represented by the symbol a, and it's measured in meters per second, which is represented by the symbol ms to the power of -2. And here's a slide showing the equations we've learnt so far in physical world, just for you to remember. So we've learnt about force equals mass times acceleration. We've learnt that average speed equals change in distance over change in time. And we've learnt that acceleration equals change in speed over change in time. Kapa, you've reached the end of this video. So by now you should be able to use this equation here, change in distance equals speed times change in time. And this equation here, change in speed equals acceleration times change in time, with the correct units to be able to calculate distance, speed, time, and acceleration. Thanks for watching, and I'll see you in the next video.